Sometimes we need applications that can communicate with external servers to retrieve data or state. This is typically done via a fetch mechanism. So how do we fetch some external data in Zig? Let's say we want to retrieve some JSON data from the JSON placeholder API. Let's start by importing everything. We'll import both HTTP and heap from the standard library, as well as bring in some types from HTTP. We'll then need an allocator. Let's use a general purpose allocator. One benefit to using the allocators provided by Zig is that they can detect memory leaks. The dinit function provided on the general purpose allocator returns whether a leak was detected or not. We can defer the deinitialization of the allocator and, using an if statement, log to the terminal whether a memory leak was detected. With the allocator set up, let's create an instance of client. The fetch method contained on client will allow us to send a one-shot HTTP request with a set of provided fetch options. The fetch options is where we specify things such as the location the fetch request will be sent, the payload to be sent, this is the body of the fetch request, and where we could send things such as JSON data in a post request, the request method, and the request headers, and many other options. Looking at the fields defined, fetch option defaults to a GET request with an empty set of headers. For our first request, these defaults will be just fine. Let's create an instance of fetch options, passing in the URL we want to retrieve the data from. Let's simply retrieve a to-do JSON object from the JSON placeholder API. With the fetch options defined, we can call the fetch method on our client instance, passing the allocator and options. Fetch returns an instance of fetch result. This struct holds information such as the response status, body, and headers. Let's save that in the variable res and defer its deinitialization. Looking back at JSON placeholder, we can see that it will return a JSON object in the following form. Let's create a struct to replicate this so we can deserialize the response body to a valid type. Calling JSON parse from slice, we can parse the JSON body to a type of our choice. Parsing the body to JSON, we can create a new to-do item like so. If the response is not JSON, we can simply handle the body as is or check against the headers field within the response and handle it appropriately. It's important to note that these requests will block. The latest version of Zig at the time of this video is 0.12.0 dev 2036 and does not support async. This means we cannot make this request non-blocking without spawning some kind of thread or process to handle it in the background. So we've seen that we can create a simple GET request, but what about POST request? Luckily, most of our logic can stay the same. Let's update the URL to now point to a JSON placeholder route that allows POST requests. Let's then update the method on the fetch options instance to be POST. Because we're posting data, we must now add extra information into the headers. To keep things simple, let's just add the content type header and set it to application JSON. We can do so by initializing an instance of headers and calling the append method. Let's create a struct according to the spec defined by JSON placeholder to hold the return data. We can now create a new post and stringify it using the stringify method. To make this example easier, we'll just use the allocating version, which returns the stringified struct. We can now specify this data within the payload field of the fetch options struct. If we wanted to send a file of data, we could also specify that within the payload struct. Now, all we need to do is call our fetch method just as before and everything should work as expected. To simplify our usage of fetch, let's build a simple wrapper around it, exposing get and post methods. Using the built-in function this, let's create an internal variable called self. This simply returns the innermost struct type. Let's also create a shorthand for the allocator type. Our fetch request struct will need two fields, one to hold the allocator and another to hold the HTTP client. With this defined, we can create an init and dinit function like so. The init method will create an instance of the client and then an instance of self, and the dinit method will deinitialize the internal client. We can now create a get method which takes in self, the URL, and any headers, and returns a fetch result. Inside, we can define our fetch options and call fetch just like how we were doing so before. While we're at it, we can also create a post method in very much the same fashion. Now, instead of initializing a client, we can initialize our fetch request struct. We can update our get request like so to use our new get method. Just like our get refactor, we can do the same with our post request and update it to use the post method. And with that, we have a full struct that allows us to do blocking, get, and post requests. You can find the code along with further resources used during the making of this video in the description below. If you have any questions, feel free to leave them in the comment section, as well as liking and subscribing if you enjoyed the video. Thanks for watching.